Hello everyone, I am Abrar. In this channel, I like to describe about different kind of problems you may see in problem solving, but I like to just uh, make some groups. Like you can just learn a problem from one group, then actually you can just apply the same approach to other problems in that group. So actually, I like to describe the problems with patterns actually. So the first pattern I like to describe or from start with sliding window. So what is a sliding window? Sliding window is nothing actually. It is this: you are given an array. Sorry, yeah, you are given an array like this, and you have some sub-arrays with different size actually, and the subarrays are described as window. So it is a window, this is another window, and this is also another window. Those are windows, and you can see like for if this is the first window, it is the second window, it is the third window. You can see those are like sliding, right? It starts from this one, first one, then it starts from this one, it starts from this one, then like this. So it just slides. So this kind of uh, patterns are called sliding window. Okay, so I think we are good with sliding window. What are sliding windows? So now let's see an example. So if it is a array, in that case, like if we take like 3 elements, then this is the first 3, then this will be the second 3, this will be the third, this will be the fourth, right? If our window size is 3, what about if we take window size as 4? So if we take window size as 4, so this is the first window, this is the second, this is the third, this is the fourth, the fifth, and this is the sixth, right? Okay, so in the window there is a pattern. You can uh, just have a look. Like it is the first. Let's just mark the windows by number. First window, second window, third window, fourth window, fifth window, and sixth window, right? And the air. So, what is the difference between the two windows? This one is going, and so from first window to second window, this one is removing, and this one is adding. What is the difference between like second window, these ones, so this one to this one, it is also the same. You can just have a look. This one is removing and this one is adding, right? So for each window we are just having just two things: one element is going and one element is adding. So by using this property we can just solve the different problems in efficient way. Let's take an example. Like, okay, so let's say uh, we are given this array. We need to find the maximum subarray of length k. So for example, k is 4 for here. K is 4. Just a minute. Yeah. Okay. K equals 4 for here. Okay. Right. So if we do by hand, what is the case? So first take this sliding window. What is the sum? The sum is 10, right? We need to find a subarray of size 4 from this array which have maximum sum. That is our problem. If you don't understand, okay. Then for the second subarray, what is the summation? Summation is 14, right? Yeah, it is 14. So for next elements, the sum is 19, right? Yeah, 4 3 7 7 7 14 19. Yeah, for next elements the sum is what? The sum is 17, right? For these ones the sum is 23, right? For this 4, what is the sum? Sum is 17 again, right? Okay, so what is the highest one? Highest one is this. This is the highest one. So 23 is supposed to be our answer, right? Okay, so if we need to just do that, just if you don't have any just intelligent algorithm, how you would like to do that? Just we will take a loop, start from here, from this pointer, and if the size is k equal 4, so we will be ended in here. Yeah, so our first for should start to end. This one is end, this one is start, right? Then there will be another for loop, right? What will be the case? For from I, from the pointer, there should be I suppose, for I to I plus this length of, okay, so like just take 4 elements from I, that's the main thing. So just have a look and make a sum to 0 in every case, and make a sum plus equal the element. Like first time take this one, then take this one, this one, this one. If the size is 4, we are just then calculate like if the sum is greater than the previous window sum. Let's have a variable that max win sum, which contains the maximum subarray sum actually. So if it goes out and comes here, then max win sum equal max of sum and max win sum, right? That will be the way. But what is the problem in here? We are doing this one is iterating through n times, and this one is iterating through k times, right? So what is the complexity? Complexity is this 2, right? N into k, that is n into k. So which is not linear, but we need a linear solution. How we can do that? So for doing that, what we have learned from previous way, we can use that. How? From the two window, the difference is like we're removing the oldest element and adding the newest element. That is the way. So how we can do that? So the base case, just make a sum. Let's have sum and max value, max or max window. So the first case, it is taking this one, so the sum is 10, right? Then for the second one, let's have like I I equals 0, then 1 2 3 4, 1 2 3 4 5. Yeah, what will be the values? Okay, so for I equals 0 it is 10. We are doing that via the loop, the initial step. Then the second one is we are removing this one, adding this one, right? So 10 minus removing that one, adding the new one, it is 14. Next case, from that one removing the oldest one and adding the new one, right? And so that's how actually, and for each stage we are just updating the max value. So for actually I equals 0, the max value is 10, and for next one the value should be 14, and for next one the value should be like that one, that way. That way actually we are updating the values, and after the loop ends at index 5 we are getting our answer, right? So why we are not going beyond index 5? Because if we go beyond index 5 then we have to choose this one, but this, if we choose this one, there is no element, like we don't have like k elements remaining, so we don't need to go beyond that. That's the approach. That's how we can just have a linear solution. But the thing is actually how it is linear. It is linear because we are never recalculating these common elements. For each case we are just reusing the value, right? How we are reusing the value? We are restoring the sum and we are using the sum in here, right? In all cases we are reusing the sum from here to here, from here to here. That's how actually we are recalculating. So let's just make another calculation so that you can understand. Just okay, 14 minus 2 plus 7, that is actually 12, like 21. Then this one, what should be like 21? Oh, sorry. So if we need to find this element, so 21 minus 4 plus 2, that is 19, right? So 12, 2, 14. It is wrong, sorry. So 14, 10 minus 1 plus 5, 10 minus 1 plus 5 is 14. Then 14 minus 2 plus 7, that is 14 plus 5, that is 19. It should be 19. It should be 19. Yeah, that is the wrong. It is 19 actually. 19. Yeah, 4 3 7 7. Yeah, 19. 19 minus 4 plus 2, that is 17. That is 17. And then 17 minus 3 plus 9, that is 23. And for the last step, 23 minus 5 plus minus 1, what is 27 again, sorry, 17 again. So our highest value is this one, which is stored in this variable. So that's how actually we are getting our answer. I think you understand those, and if you don't understand, please let me know. I will try my best to give all the answers you need, and let's see how the code looks like. So yeah, I will give the link of this problem in the description so that you can just easily understand this as well. So we are given an array, a sliding window size. So this is the solution in Python actually. So array is array, n is the length of the array, and k is the sliding window size. This is the invalid case. So sliding window size is less than the array size, so it is invalid. And it is the base case. We are generating the base case. So after that we are just iterating through each element and updating the answer actually for each case. This is the current Windows sum. That's how actually it is done. Thank you for your time, and please let me know.